Hello, and welcome to Homework 5.01, our first homework in the graphing unit. All right, so this homework is going to look at a lot of just some of the basics of kind of working on the coordinate plane and graphing points and some introductory lines. All right, so question 1 says, on the set of axes to the right, fill in the quadrant numbers in the boxes. All right, so the key here is just kind of remembering where the different quadrants go. All right, so the first quadrant that we use is the one on the top right. This is where both our numbers are positive, both the x and the y. This is quadrant 1. We're going to use the Roman numerals. That's just kind of the convention there. And then from there, we just go counterclockwise. So this is going to be quadrant 2. This is going to be quadrant 3. And then over here is going to be quadrant 4. Okay? So that takes care of that first question. The second question says, state which quadrant each of the following points lie. All right, so the first step here is going to be to kind of graph these points and see where they are. So anytime we have a point, we have two numbers. The first number is our x, so that's our left to right. And then the second number is our y, and that's going to tell us how much we go up or down. So when we have a positive 1, positive 3, we're going to start at the origin. We always start in the center here. And then we're going to go over 1 because it's a positive 1, so that's to the right 1. And then up 1, 2, 3. And when we make this point, we can see that it lands in quadrant 1. So our answer to this first one is quadrant 1. All right, if we take a look at the next point, negative 4, negative 6, because it's a negative 4, again, we start at the origin, we're going to go left 4 this time. So 1, 2, 3, 4, or you can also think of that as back 4. And then with a negative 6, we're going to go down 6. So 1, 2, 3, 4, 5, 6, which is going to end up our point down here at the bottom of our grid. And we can see that that falls in quadrant 3. So that's going to be our answer to the second one here. All right. If we take a look at question 3, it says state the coordinates of the origin, which is usually labeled with an O. So the origin is always in the same spot. It's right in the center of our grid, which means we're not going left or right at all. We're not going up and down at all. So both of those are just zeros. The x is a 0 and the y is a 0. Those are the coordinates of the origin. All right, let's take a look at number 4. Fill in the xy chart below for the linear function y equals 2x minus 2 without the use of your calculator. Then graph the equation on the axes to the right. So this is kind of making you do it the old school way. In class, we learned how to do it on the calculator, and that's how we're going to do it in most times, but this is just like one last practice for old time's sakes, doing it by hand. So our equation is y equals 2x minus 2, so what we're going to do is we're going to pick a bunch of x's. So in this case, we're going to use negative 2, negative 1, 0, 1, 2, plug them in by hand, see what the y ends up working out to be, seeing what it equals, and then turning that into a point that we can actually graph. So if we do these, let's just go through them here. This one we're plugging in a negative 2. So then we would do 2 times negative 2, which would give us a negative 4. Negative 4 minus 2 is negative 6. So our first point would be negative 2, negative 6. So our first coordinate is just negative 2, comma, negative 6. Next, we would go ahead and plug in a negative 1. So it would be 2 times negative 1 minus 2. So 2 times negative 1 is negative 2. Negative 2 minus 2 is going to be negative 4. So this one's going to work out to be negative 1, comma, negative 4. And then we just keep going down. So we've got 2 times 0 minus 2. 2 times 0 is going to be 0. 0 minus 2 is negative 2. So we've got 0, negative 2. And once you've done a few, you can actually start to see the pattern. All right? The y's keep changing by 2. So it goes from negative 6 to negative 4 to negative 2. So if I had to guess, the next one's going to be 0. But let's actually go through it and see what happens. 2 times 1 minus 2. Well, 2 times 1 is just 2. That's the identity property there. When you multiply it by 1, it doesn't change. So 2 minus 2 is 0. And look at that, our pattern holds. So this one would be 1, comma, 0. And then if we do this last one here, we've got 2 times 2 minus 2. 2 times 2 is 4. minus 2 is 2, so that gives us the final point that we're going to use when making our graph here, which is just 2, 2. All right. So now we've got a whole bunch of points. So what we're going to do is we're going to take those points, we're going to bring them over to our graph, and hopefully they're going to line up in a straight line that we can then connect. All right, so let's just go through these one at a time. All right, negative 2, negative 6 is going to be back 2, down 6. Negative 1, negative 4 is back 1, down 1, 2, 3, 4. 0, negative 2, when we have a 0 for the x, that just means we don't move left or right at all. We stay in the center, and then we go down 2. 1, 0 is going to be over 1, but then since our y is 0, we don't move up or down at all. We just stay right on the line. And then finally, 2, 2 is going to be over 2 and up 2. And just notice that on each of those, I always started from the origin. I started from the center and counted from there. All right, so now I've got my points. I'm going to connect them. So I've got my nice line here. Notice I don't stop my line at the point, all right? The graph keeps going. It doesn't stop at your last point. There's actually an infinite number of points on your line, so it goes all the way through the points. I put some arrows to show that it keeps going. And then last but not least, we want to put a label on our graph, and we just label it with the original equation. So the label for this graph would just be y equals 2x minus 2. It's kind of like giving the line a name. That's the name of the line, y equals 2x minus 2. Okay, so that's how we would do one of those by hand, and that's probably how you learned to do them last year. All right, let's take a look at these next ones here. Solve each equation for y in terms of x. So basically what that's saying is we need to get the y by itself. And we're going to see this a lot in graphing. Anytime we want to graph a line, our first step is going to be to get the y all by itself on the one side. So if we look at this first one, we've got a couple things that are in the way. We've got to get rid of this 5x, and we've got to get rid of this negative sign that's in front of the y. We need to get rid of both of those so that the y is on the one side all by itself. And we do that the same way that we do things with equations. All right, so if we want to move a 5x from one side of the equal sign to the other, we just do the opposite. So this is a positive 5x. The opposite of a positive 5x is a minus 5x. So I'm going to minus 5x from both sides. These will cancel out. So I can bring down this negative y. Don't forget that negative sign. That's a common mistake. And then here, I can't actually combine these because they're not like terms, so I just write it as negative y equals 12 minus 5x. And then my last step is this negative y is really a negative 1 times y. We just usually don't write the 1 in there. So if we want to get rid of it, the opposite of multiplying by negative 1 is dividing by negative 1. And when we divide, we have to make sure that we divide every single term. So our final answer is going to be y equals negative 12, and then here we have a negative divided by a negative, so that's going to turn that to a positive 5x. Okay? So let's try another one of these. Here we have 6x plus 2y equals 8. So again, we've got two things that we need to get rid of. We need to get rid of that 6x, and we need to get rid of the 2. Those are the two things that are preventing the y from being by itself. So we'll start by subtracting 6x from both sides. These will cancel out, and we'll be left with 2y equals 8 minus 6x. And then we need to get rid of the 2. That's 2 times y, so the opposite is to divide everything by 2. And then we're left with y equals 4 minus 3x. All right, let's take a look at the back. Given the equation 3x plus y equals 1, solve the equation for y in terms of x. Okay, so that's the same thing we were doing before. We've got this equation, 3x plus y equals 1. We need to get the y by itself, which means we need to get this 3x over to the other side. So I'm going to subtract 3x from both sides. These are going to cancel out. And then let me write it over here. There's a little more room. So I'm going to be left with y equals 1 minus 3x. All right, so that's step 1. Step 2 says create a table using your calculator. All right, so this is where we can make use of our graphing calculators. All right, so let's get a graphing calculator right here. All right, if we want to graph one of these, we just go to our y equals. That's the whole reason we got the y by itself. We would type in 1 minus 3x, because that's what we ended up with after we solved it. And then we would go to second graph, because that's going to bring up our table. And then what you'll see here is you'll see a table of all the different values. You know, this is what we did on the front by hand, only the calculator is kind of doing it for us automatically. When I'm doing these, I usually try to get a mix of sort of like negatives and positives, but you also want to make sure that they're going to fit on your graph. Like if you look at our graph, we only have, 6 squares up and 6 squares down. So we don't want to use like numbers that are going to be giant because then they're just not going to fit. So why don't we use, we'll go from -2 to +2. So if we go over here to our chart, we've got -2, 7. We've got -1, 4. We've got 0, 1. We've got 1, -2, and we have 2, -5. So I've got a balance of both positive and negative x's. All right. So if I want to make these look like coordinates, I can just throw the parentheses around them and just notice the x is always coming first. So -1, 4, 0, 1, 1, -2, 2, -5. And then it's just a matter of kind of going through and graphing those. So -2, 7 would be back 1, 2, and then up 7. 1, 2, 3, 4, 5, 6. And then I don't actually have 7 boxes, so I'm just going to kind of estimate it and put it right up there. All right, the next one is -1, 4, so I go back to the center. The negative means I go back 1. The positive 4 means I go up 1, 2, 3, 4. The next one is 0, 1, so that means I don't go left or right at all. I just go up 1. The next point is 1, -2. So since the 1 is positive, I go to the right. The 2 is negative, so I go down. And then the last one is +2, so I'm going to go over 2. And then -5, so I'm going to go down 1, 2, 3, 4, 5. All right? And you're going to see that all my points kind of line up in a row. If you ever get one point that's like way off in another direction, it probably just means you made a mistake somewhere. So let's connect our points. Notice my line is not ending at the points, it's going right through it. And then I'm just going to put arrows on both ends to show that it keeps going. And the nice thing here is my arrow is pointing right at that last instruction, which is to put a label on it. So I'm just going to label it with the original equation that the problem gave me. So that was 3x plus y equals 1. I'm just going to label it with the original equation that was given to me. Okay. Number 7. Consider the linear equation 2x plus 3y equals 9. Does the point -3, 5 lie in the solution set of this equation? Justify. All right? So what we can do is we can basically just plug this point into our equation and see if it checks out. Remember, when we have a coordinate, the first number is the x, the second number is the y. So we can take this 2x plus 3y equals 9, and we can just plug those two numbers in. So in for x, I'm going to plug a -3, so it's going to become 2 times -3 plus 3, and then for the y, I'm going to plug in the 5. All right, so then if I do that, 2 times -3 is -6. 3 times 5 is 15. So -6 plus 15 is going to work out to be 9. So I end up with 9 equals 9, which means this checks out. So when it says, does the point lie in the solution set, the answer would be yes, because it's checking out. All right, so if those two numbers had not been equal, we would have written no, but since the two numbers are equal, it checks out, and we can write yes. Now the second part of that equation says, does the point -3, 5 lie on the graph of this linear equation? Explain. And what you need to know is that a line is basically a visual representation of every single answer. Every point that checks out is going to fall on the line. The line is showing you all the millions and millions and actually infinite number of points that will work for that equation. So in our case, that point checked out. So is it going to be on our line? Yes, because the point is a solution. All right, so yes, because the point is a solution. All right, last question here. The graph of a linear equation is shown on the axes below. Answer the following questions based on this graph. For what value of b is the point 0b a solution to this linear equation? Now remember, solutions have to be on the line. So what we're basically looking for is what is y when x is 0. All right, so if we go and look at our picture here, when x is 0, that means we're not moving left or right at all. So if we find the point that has x at 0, we're going to see that it's this one right here. All right, that's where x is 0, and it's where y is a positive 1 because it's 1 point above the origin. So for what value of b is the point a solution? The point would be 0, 1. Okay, so that should wrap up this assignment. I hope this was some help. Have a nice day.